Hi everyone, welcome to our video on parallel lines and perpendicular lines. So parallel lines do not intersect in the XY plane. So for instance, say I have a line right here. A parallel line will not cross it in any way. So these two lines are parallel. Parallel lines have the same slope. Okay, so the same slope here. So whatever this slope is matches this slope for that line. Perpendicular lines intersect at right angles or at 90 degrees. So for instance, if I have some random line like that, a line that's perpendicular to this would cross it at 90 degrees. Okay, so it crosses it at a special angle. So we usually use that little square thing to show 90 degrees or right angles, and then, well, I'm just putting in 90 degrees right there as well. Perpendicular lines have opposite reciprocal slopes. So opposite means opposite, like sign. Choose whatever the sign is, opposite. And then reciprocal, remember, means to flip. Okay, so we'll break down those cases. So for instance, let's look at a parallel line first. So they say line L is parallel to y equals f of x. And they sketch the one in like the light gray. What is the slope of line L? Okay, well, if they're parallel, that means I want to find the same exact slope. Okay, and this, it shows some point. So we can find, so these have the same slope. So wherever I want to choose it, and here they gave us a point, I could try to find where it might cross. It looks like right here is where it crosses a grid point. Okay, it's a little tough to see, but I think that's where it crosses. And so we can just count the rise and the run. Okay, so we've got, and we can label this point 2 if we need to. So there's 2 and -3. Okay, so it looks like from 2 to 6, so 1, 2, 3, 4, so that's a length of 4. And then from -3 up to -1 is 1, 2. So we have a length of 2 for the rise and 4 for the run. And so this line has the slope of 2 over 4, which reduces to 1 over 2. And it should stay positive because it is going up from left to right. And then, well, this line has the same exact slope. So I can just quit right now and box it. That's fine. It looks like I would have enough information, though, to try to find grid points to really verify. So it looks like it crosses here and crosses here, and then, well, looks like it goes 1, 2, 3, 4, and then up 2. So our run is still 4, our rise is still 2, so it still looks like it matches. Okay, so these have the same line, or these have the same slope, these parallel lines. Okay, so they gave us more information than what we needed because, well, we didn't really need the other line, but hey, sometimes they do that, and that's nice of them. Okay, so let's break down these, though, where we're finding both parallel and perpendicular. So here I just wanted to show a picture. All right, here we've got the line that would be, let's do A right here, and we'll put B over here. Okay, so the line y equals -4x minus 1. Well, this line has a slope of -4. So the slope of a line that's parallel to this is the same slope. So it is -4. Perpendicular, we want to do opposite reciprocal. Okay, so opposite sign, the opposite sign of -4 would be positive. So I'm going to put a little plus for now. And then reciprocal means to flip. Remember, this really is 4 over 1, so I can flip that as 1 over 4. And then, well, we usually don't show that positive like that. So our slope would be 1 over 4. Just like that. Okay, so there we go. Okay, so it's often pretty quick, again, to find it depending on the scenario. Okay, so with this line, well, we want it in the form that's good for us. We need to solve it. We need y equals mx plus b. So that means we should solve for y on this problem. Okay, let me still mark A right here and B over here. Okay, so let's solve for y. Well, to start solving for y, we can subtract the 2x. And I'm just kind of squeezing it in between there. So 2x minus 2x would be 0. Negative 4y drops down. And then let's put the negative 2x first and then plus an 8. And then now we can divide everything by negative 4. And then that way we get y all by itself. So we'd have y equals negative 2 divided by negative 4 would be positive 1/2. And then x is attached. And then 8 divided by negative 4 would be minus 2. Okay, so let me cloud this one. Okay, and well, this line kind of went into my other part of the problem there, but this line we can see is the slope is 1/2. Let's just put it over here. So we've got the slope is 1/2 for this line right here. So a line that would be parallel to this line, again, has that same exact slope. So it's just instantly 1/2. And then to break down the perpendicular case, we're still using, let me scroll just a little bit, opposite reciprocal. Well, currently it's positive 1/2, so the opposite sign would be negative. And then flipping 1 and 2 would be 2/1, just like that. And then, well, at this point, we probably wouldn't write 2/1. We would just write negative 2. Okay, so that's how we could do these. So we just break down and just make sure we're doing the correct case. Okay, with this, we've got, all right, so again, let me label A, B. So they're saying we have a line that would be, one, parallel with the x-axis. So here's our x-axis right there. All right, so parallel to the x-axis, let's go ahead and say, well, a line that would be parallel to the x-axis would be something like this. And we can see, well, that's a horizontal line. Actually, let's go ahead and just say it over here. So a line that would be parallel to the x-axis is a horizontal line. And while that's one of our special cases, the slope of a horizontal line is instantly 0. Okay, and well, we can still even use that 0 to help us with B, because we can technically say 0/1. And then if you flip these, so if we flip 0 and 1, oops, or 0 up top, I didn't flip it. So if we flip it, we would have 1/0. And then, well, at that point, we could say 0 in a denominator means that it's undefined. And so we have m is undefined. Okay, so we could use that slope to help us with B, or we could draw it in. Okay, so a perpendicular line to the x-axis would be something like that. So there's the 90 degrees. So here's our perpendicular line. Well, a perpendicular line to our x-axis would be a vertical line in this case. And that's, again, a special case. The slope of a vertical line is undefined. So that's what's really good about math. A lot of the times we can kind of double-check things with other scenarios. So on this one, we showed we can do it with the number part for part A and then flip it. We also showed, well, using the definition of a vertical line, we've got the slope is undefined also. Okay, and then one other, here they're doing the y-axis. Okay, so, well, that's the y-axis right here where I'm putting the big arrows on. So there's our y-axis. And then, well, if I want a line that is parallel to the y-axis, so here's our parallel line. Our parallel line is a vertical line. So for A, we do have a vertical line this time. We just talked about a vertical line has slope that is undefined. And then for B, so let's keep it in purple. So for B, part B, the perpendicular line, well, perpendicular to y would be a horizontal line. That's where we would get a right angle. And so here we've got our perpendicular, let's just say perpendicular to y. Let's make sure we have it right. So parallel line to x. Oops, actually, let's say y-axis. I was thinking x for some reason. Perpendicular to y-axis. Let's add that. There we go. Anyway, so writing more stuff than we probably need. But we can see that it's a horizontal line. And again, we have the slope of any horizontal line is instantly 0. So that's it. All right, so we're all done. Okay, so those are some of the special cases with perpendicular and parallel. So remember, parallel have the same slope. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Okay, and then we'll put that to use more in the next couple videos. All right, thanks for watching, and I'll see you again soon.